Hello, my name is Mustafa Al Nasser.
And my name is Muhammad Al Musa, and we are Jawatha Nexus.
We noticed there is a global issue, and that issue being people lost in the desert without a signal, or people getting stuck under rubble due to disasters such as earthquake and tornadoes.
Every single time we hear about people being reported missing in the desert or the collapse of a building due to disaster, we know that multiple deaths and injuries are often reported. And we know that rescue teams work tirelessly to save as many lives as possible. And for people trapped in confined spaces, we know that every single second can be a matter of life and death, which is why we created
Selix, an autonomous mobile robot optimized for rescuing humans in need of help, such as when they're lost in the desert without a signal or stuck under rubble.
It performs real-time object detection using YOLO V8 to locate people trapped under rubble.
Also, Selix uses threads instead of traditional wheels, giving the robot a better grip on all sorts of terrains, such as when walking on the sand. Using threads gives the robot more stability. And we added a 3D printed layer, giving the robot a smooth walking experience on hard surfaces.
It uses a 3D depth camera for navigation and mapping, creating an accurate 3D map, and a thermal camera for locating people trapped under rubble.
Selix uses also a solar panel as a secondary power source in case the main battery dies. The solar panel is really efficient in the desert since the sun is extremely hot in there. And the robot's fully 3D printed. We use the 3D carbon fiber, making the robot durable and lightweight.
Selix is also equipped with a gas sensor that can detect multiple dangerous gases, and this makes it a vital tool in rescuing oil field workers who often face life-threatening risks in the form of undetectable, explosive, or even poisonous gases.
And we want to show our prototype for Selix. This is our first design of Selix. The major issues were with this design, that this used a rubber thread instead of 3D printed ones, making the robot lag on surfaces such as sand. And the robot was extremely small inside, limiting our space to adding Raspberry Pi 4 and motors.
Selix, although has an incredibly advanced design, is very cost-effective, costing only about $800 USD, making it very accessible for any community to use.
Also, we want to show you gameplay of Selix. As you can see, Selix moves smoothly with threads. We want to also show you the thermal camera. As you can see in the screen, Selix uses a thermal camera to detect people's spots if they're stuck under rubble, giving the rescue team an idea what they're dealing with.
In conclusion, Selix showed immense promise in rescuing lives by decreasing the amount of time it takes for rescue teams to search and rescue victims trapped under rubble. Combined with autonomous navigation and accurate precision in human detection, it will change the operation of rescue emergency responses.
Thank you for listening.
Thank you for listening.